you want to reconfirm the class and see what we think? Alright, so we've done a little bit of graphing derivatives. We talked about, the slope of the tangent line. I'm going to show you how to do basic derivatives algebraically. Then we're going to start kind of combining that with the graphs so you can get an idea of, like, here's how you find it with the algebra. Here's what you're actually finding. Here's how to do some of the problems. So the general, like the very basic derivative rule is the power rule. I don't know if you guys got to this in pre-calc or not last year. It is familiar? Okay. So if y equals x, let's say ax to the n power, the derivative, so I would indicate derivative, there's a few ways I could do it, I'll go through all of them. Y prime would be one way to say the derivative. Would be bring down the n and multiply it by the number that was in front, so n times a. Leave the x there, and reduce the power by 1. So if you remember the wiggles thing, like remember how I said when you take the derivative, you go down a wiggle? This is why. So when you take the derivative, you're going down a power. So like an x cubed graph would have 2 wiggles. When I take the derivative of that, I'm going down to an x squared, which has 1 wiggle. When I take the derivative of that, I'm going down to an x, which has no wiggles. So every time you take the derivative, you're knocking a power off, and therefore you're knocking a wiggle off. I could also write it as dy over dx equals. Same thing, I'm just showing you kind of different ways that can be notated. Or it could be like if f of x equals ax to the n, then f prime of x equals, again, same rule, just write it different ways. And derivatives can get pretty intense. There's product rule, chain rule, quotient rule that we're going to get into. There's implicit differentiation. There's all these different methods and types. There's trig, there's ease, there's ln's, there's all that stuff. For now, we're just doing like the very basic kind of intro stuff. So nothing that we do today or probably tomorrow or Monday will be anything beyond just this power rule. So just start with like a basic example. Let's say I had like 4x to the third minus 6x squared plus 7x plus 8. So the derivative of 4x to the third, you just take, this is just like 4 derivatives at once. You just take all 4 of them and add or subtract the same. You just do it one at a time. So I bring down the 3, multiply by the 4, that's 12. Reduce the power by 1, so that's 2. 6x squared, so I bring down the 2, multiply by the 6, multiply by the x, reduce the power by 1. So that is just x now, right? And then this next one, there's a couple different ways you could look at this. There's a shortcut rule for this, but technically that's to the first power. So I'm going to bring down the 1, multiply it by 7. And then I'm going to reduce the power by 1, so it'll be x to the 0. Well, what's x to the 0? What's anything to the 0? 1. So there's no more x. So it's just gone. And we'll talk about that more in a second. And then this is technically right now 8x to the 0. Because what's x to the 0? 1. Okay, so bring down the number up, bring down the power, multiply by the number in front. What do we get? 0. So the constant just disappears. And that would be my answer. But let me back up a second and let's look at those two special cases. Let's say y equals 7x. I'm telling you the derivative is 7. Tell me why. Without using algebra. Yeah. I'm not going to argue with that. But that's not what I'm looking for. Tell me why. Like, what does it mean? What are we finding? Why? I mean, it's a logical thing. No one just randomly decided, hey, let's just make 7x turn into 7. Why is it 7? Why, if I give you y equals 7x, would the derivative be 7? Yeah. So what does derivative find? Derivative is slope. Derivative and slope are the exact same. Like, you got to get those kind of interchangeable in your head. Derivative is slope. So if I gave you that and said, hey, what's the slope of y equals 7x, what would you say? I would hope you would say 7. So if I say, what's the derivative of 7x, and you'd say 7, then when I say, what's the slope of 7x, you would say 7. So it's the same idea. So if I give you y equals kx, what's the slope of that? Slash, what's the derivative of that? K. And all that is just slope of a line. So, okay, y equals mx plus b. What's the slope? M. What's the derivative? M. I mean, they're basically the same question. Then we did this y equals 8, and the derivative disappeared. It became 0. Why? Mythal. What do you mean there's no slope? Yeah. So what kind of line is y equals 8? Don't say straight. Horizontal. And what's the slope of any horizontal line? 0. So this is just... So if I give you y equals k, what's the slope? What's the derivative? 0. And that's because that's the slope of a horizontal line. I knew what you meant. I just wanted you to say 0 instead of no slope. Okay, so y equals, I don't know, 8x squared minus 6x plus 7. What's the derivative? 16x. So there we're actually using the power rule. And this you can think about as the power rule if you want, because there's a 1 there, so bring the 1 down times the 6, reduce the power by 1, x to the 0 is 1, so it goes away. Or you can just think about it like the derivative of k times x is k. And then what's the derivative of this 7 out here? Nothing, it just goes away. Easy enough? Do this one. It's about as tricky as I'm going to make them today. It's probably even trickier than anything on your homework. So bring down the 1/2 times 4 is 2. Reduce the power by 1, so what's 1/2 minus 1? Negative a half. This would be 6x. This would be 6. And what's the derivative of pi? 0. Pi is just a number, right? I mean, it's like a fancy number, but it's just a number. So that's a horizontal line at pi, and the slope of that is 0. Questions there? Yeah. I will. I'm not worried about it right now. There are certain times I'll want you to, certain times I won't, and we'll get into that like down the road. So for right now, you can just leave it. If you did, though, I mean, if you wanted to, it'd be 2 over x to the 1/2, right? So if you, I mean, either way, they're both correct. Okay, for this next part, let's look at your homework because it's drawn out a lot better than I could ever draw it. So I'm just gonna do a couple of these with you. Get you the rest of the time to work. I think today's a pretty simple day. Yeah, I gave it to people that came to class. Jeez. Are you alright? Okay. Do you get those often? Is that like a random? Don't tell me that. Okay. Find the instantaneous rate of change. What is a much simpler word for that? Derivative works. What else? Slope. All of those things mean the exact same thing. And the AP test will use them interchangeably, so you gotta kind of know what they all are. I'm on number 11. So derivative, slope, instantaneous rate of change. So I'm going to take the derivative of this function here. So h prime of r. Do you guys have a question? I'm kind of concerned about it, though. Okay. Now I hear a high-pitched tone in there. Does anybody else hear a high-pitched tone? You're contagious. Oh, mine's not that extreme. Okay. This happens sometimes?
Yeah.
Does it just go away?
After sometimes, this is probably one of the longest it's ever, it like comes in waves, it like fades and then gets worse and then.
Are you stressed right now?
It's happened. Yeah, I've had quite a bit of stress lately. So.
Really? I'm sorry. Yeah. Okay. Are you good if I move on? Or? Okay. So, here's the equation. They graphed it for us, and then my job is to find the derivative or the slope or the instantaneous rate of change when x equals 1. So like last night you guys sketched this. So you'd put the dot here and you'd like sketch your tangent line. Or this was the night before, I guess. And then I could ask you to estimate the slope of that. But we don't have to estimate the slope of that anymore. We can actually find the slope. So what we're finding is the slope of that line. So what's the derivative of r squared plus 2? 2r. What that means is no matter where I am on this curve, and r is just x, right? It's just like the x value. No matter where I am on this curve, the slope is 2 times the x value. So if I were here at x equals -4, I mean it's way up there, but that would mean that my slope here was -8. My slope at -2, right here, would be -4. I'm just 2 times -2. What's my slope at 0? 0, because 2 times 0. Well, they're asking me for the slope at 1, so what's the slope at 1? 2 times 1, which is 2. But what this gives you is, you can plug in any x value you want, it'll tell you the slope of that graph at that spot. So that's what a derivative does. It tells you the slope at any spot you want on the graph. So then I would say, okay, that means h prime of 1 equals 2 times 1 is 2, and that's my answer. So we're not estimating anymore, we're not eyeballing, we can actually do the math, connect it to the graph, and say, okay, here's what we're finding. So that means the slope of this line is 2, which I may not have drawn very well, but that's a different story. Man, you interrupted the test by sneezing, you interrupted my lecture by sneezing. Bless you. Questions on 11? Let's do 13. So it's the same idea. I'm not doing anything new, I'm just doing it again. At x equals -2, I want you to draw all these too, because I want you to get used to okay, here's the math, here's the graph, here's kind of how they connect. So go to -2, put your dot, try to draw your little surfboard guy, or look at Jack putting his arms out or whatever you do.
Can I drop off the shirt?
I mean, you're already here, you just kind of came in, so... Bring me a shirt?
Did you order one?
No. Probably don't make them big enough. Alright. So, this should be, I'd say, negative something, right? A little bit steeper than -1s, like -3, -4, -2, I don't know. But we can find it exactly. So, what is f prime in this case? 2x plus 1, right? So no matter where I go on that graph, the slope is 2 times the x value plus 1. Well, the x value here, so I'm going to go f prime of negative 2 is 2 times negative 2 plus 1. So f prime of negative 2 equals negative 3. And that is the slope of this line. That makes sense? Good enough? So let's go to the next section. Let's say 21. So I'm adding a step to it. So after you find that slope, then we're going to find the equation of the tangent line that goes with it. So, as soon as I see equation of the tangent line, I'm writing this down. It's like a reflex. It's automatic. I'm going, okay, that's the equation of a line. And I got 3 spots to fill in. That's the x value, which they gave me. That's 1. That's the y value, which they don't have to give you. Like if I just gave you x equals 1, could you find the y value here? You would just plug in, right? But they were nice this time. They gave me that. So that's 2. And then this is the slope. Slash, it's the derivative. So then I'm going to do what I did on like the previous problems we just did. So what is g prime of x squared plus 1? 2x, right? I forgot to draw my point in here. So 1 comma 2 is here. Now we're not just finding the slope of that line. We're trying to find the actual equation of that line. So now what goes in this blank has to be a number. So I'm not going to plug the 2x in there and like distribute it out, because if I did that, I'm going to end up with like an x squared, and I don't want another variable in there. I want a number. I want to know the actual slope when x equals 2. So I want g prime of the x value I'm working with. So g prime of 1 is 2 times 1. And so your slope is 2. So that number is what goes in that blank. And then I'd want you to put it into slope-intercept form. So you're just like distributing and combining the terms. So this would be y equals 2x. What's 2 times negative 1? Negative 2 plus 2. So those just go away, right? So this is just y equals 2x. So I didn't quite draw it right because it technically should be going through the origin. But pretty close. So now we're drawing that little surfboard line, and we're finding the equation of that surfboard line. How's that one? Seem all right? I'm going to do one more. Let's do 26. So I'm going to draw it first. So negative 1, 1 is like right there. So if I draw my surfboard, it's something like that. This one might go through the origin too. We will see. I want the equation of the tangent line, so right away I'm just writing down that general form. I've got 3 slots to fill in. What goes in this slot in general, not the number? X value, what goes in this slot? Y value, what goes in this slot? Slope. So negative 1 is my x value, 1 is my y value. This is like plus 1. Then I'm going to take my derivative, so h prime equals 2r plus what? What's the derivative of r? 1, right? Because that's like 1r, and then the 1 drops. So h prime of negative 1 equals 2 times negative 1 plus 1, which will equal negative 1. So that's my slope. And again, what goes in the slope spot has to be a number. You're not putting like the derivative with variables in that spot. You're finding the slope and putting a number in that spot. That negative 1 goes here. And then I'm going to distribute and combine like terms. And again, this one goes through the origin too. They don't all. It just happened to be the 2 I picked. But negative 1 times x would be negative 1x. And then negative 1 times 1 is negative 1. Plus that 1 will just cancel and you just get negative 1x. Yes, ma'am.
So then that, the
That's the equation of the tangent. This is the slope, and this is the equation. That makes sense, right?
It's just
Okay.
we did last year pretty good. It's super complicated. That's not even standard. I don't know what we did last year.
Well, part of it is like, I mean, once you've seen it once, the second time it's easier, you know. And these are not like hard equations either. I don't know. Like we'll get to where it's harder, but are there questions on anything I showed you right now? I'm half blind, so. But thank you. I appreciate the intent. That's all I got. So I'll give you this time to work on it. Tomorrow we'll get into more like tougher derivatives, where it's not just like twos and ones